I got a new microphone. It's exciting. It required a mixing board and a lot of other cords and equipment to make it work. Uh, I apparently always have to do things in the most difficult way possible. I will seek to avoid that in this video. This video is going to show you how to use R, which we downloaded and installed R in our studio last time, to ingest a data file from Darwin's Demons and do some simple visualizations. So it should be fun, and I hope that if you're taking this trajectory through the lab with using the sort of online option, the games and simulations, that you're going to find that these skills with R build your data literacy, data science skills, and they're going to be things that you can use in your career for years and years and years. This is the new world now in terms of being able to manipulate data. So, all right. So when we last left off, I hope that you got to the point where you're staring at this kind of screen. It's a fresh new RStudio screen with an empty environment and no plots or files or anything to look at, and it's just a console, which for many of you is going to be kind of scary in terms of just single command line manipulation. But don't worry, we're going to open up a new window that makes that a little less intimidating. But first, what we need to do is go find the data file that we made in a couple of videos ago and put it in what we call a working directory, a place that's easier to find, and you kind of are doing all your data science work and your analyses in that directory. The easiest way to do that is to open up Darwin's Demons. Eventually, once you get really familiar with this, you can set up a shortcut to the directory where Darwin's Demons puts your data. But for now, let's just do it this way. All right. So open up Darwin's Demons, go to Options, click Open Data Path. It should bring it up and supersede the game, but if it doesn't, it'll be open for you when the game quits. Now, what I'm going to do is, I'm done with Darwin's Demons now. I just needed it to point me to this incredibly complicated data path that Unity requires we use. So I'm going to go ahead and quit out of Darwin's Demons, because I can see right now that my Finder window on a Mac is open to this folder called Data. The path is down here at the bottom. Just come over and make sure it's showing you on the video there. And you can see it's kind of complicated. It's hidden in this application support folder and things like that. You can make a shortcut to this, which I've actually done up here, but I can't remember how to do it. So what I want you to do, if you've done it the way I've done it, I cleaned out my data folder and then played the game once for 15 or 18 generations. So I have one data file in here, and I can tell I played it on September 3rd at, it looks like, about 1:37 p.m. If you've played the game multiple times, you'll have multiple data files in here, and so you're going to have to kind of teach yourself how to recognize which are the most recent ones, which ones are the ones you want for a particular experiment. What we're going to do here is just copy this data file, so Command-C on a Mac, Control-C on Windows. So now that I've copied this, I'm going to go to my desktop, which is just an unholy mess these days, unfortunately. You can put this anywhere you want. You can put it in documents, wherever you want, but I'm just going to put it on my desktop. And once I'm on my desktop, I'm going to create a new folder, and I'm going to call it Bio315 Online. Navigate to that folder, Command V or Control V on the PC, and I've pasted that data file into this new directory. So now we're going to do some rudimentary coding in R. First thing that you do once you're back to RStudio, and just as a reminder, over here on the left is the console window. So this is R. This is what it looks like when you're working inside R in the command line environment. Let's call it the console. This is the environment window that shows you all of your created objects and data frames and things like this. And this is more of a file input and output window is, I guess, how you would think about it. First thing you want to do is go New File, File, New File, R Script. And that opens a fourth window for you. And it's called Untitled because the script does not yet have a name. But this is where you write essentially a program, a series of commands that you can submit in a batch to the R environment, and they will run in order and that kind of thing. And so this is very much like programming in other languages where you write the script and then you submit it when you think it's ready to be run. And in the case of R, you can actually select different pieces and submit only those. And so it's quite powerful relative to clunking through making graphs in Excel. So we've created an untitled script, and now what we want to do is just find a way to ingest that single data file in our working directory. So I'm going to see if I can do this from memory. So once we're up here, the first thing that we want to do is do something called set the working directory. Okay, and so you type set WD, that stands for set working directory, and then open a set of round brackets, and then inside, I believe we're going to use quotation marks. And what we want to do is figure out, okay, well, where is my my file? And on a Mac, you can go copy this, right click on that directory, and you can copy it, go in here and paste. And so inside there, I have /users/Barry/desktop/Bio315 online, and then I believe we have to end it with a slash. And that is a command that says, hey R, when I don't tell you otherwise, the default place to look for stuff or write stuff is here. And to submit that command, you just hit Command Enter on a Mac or Control Enter on a PC. And then now we're looking at our working directory. The next thing that we want to do is a really simple ingestion of that data file into our environment in R. If you go over to this environment area, which this is all the things R creates and knows about. Right now it's empty, but we are going to import a data set. I'll show you how to do this in a batch later, but for now we just have one data set and we're just going to import it. So you click this button and you have a variety of options. Some of these may not appear on your installation of RStudio and R just yet because it's possible you don't have a particular package installed. But I think when you install R just very recently, you should be able to import a CSV dataset. So all the files we're going to be working with are comma-separated values files, .csv files. And so if we import dataset from CSV, we get this little handy user interface that makes it pretty easy. And it also, this is a graphical user interface, which will be very easy, but what it does is it also shows you, if you wanted to do this in code, it shows you how to do this stuff in code. We'll skip that for now. So you click Browse, and of course, because we've set our working directory, it immediately, the default place to look is in our working directory. And so it's like, here's what's in your working directory. There's only one file in there. I click once on it, hit open, okay? And then it sort of populates and it says, here are the variables that I see in that file. Here's its name, You can skip rows, you can do all sorts of stuff like this. I really never manipulate any of this stuff. Let's just leave it all as defaults. Okay. And then so we've selected that. If we wanted to run this code, we could copy that in and paste it into our script, but I don't really worry about it too much for this. Click import. And so here's a couple of new things have happened. So first, the console. This is the commands that we executed in the console, and so it executed these commands that I was showing you in the background. When you see red text, you should always check that out because it's either a warning, as in this case, or an error, which would be bad. In this case, it's fine. And so it executed that text, and the end of that text was view this data 9.3.13.37 thing we just imported. And that is why you now have two tabs up here in the top left. You have our untitled script, which we're going to save as a file name very soon. And then you have a view of the data. I'm going to go ahead and widen out my RStudio window a little bit so it's easier to see. Just want to give you a preview of what we brought in as a new data file. So let's start over here in the environment. You can see now the environment is not empty. Under this heading data, it has this thing that has a name. You can click on this drop-down arrow and it shows you all sorts of information. And then you unclick it because it's like, that's terrifying. I don't want to know that. But what this tells you is we have a new data object called this. There are 1,482 observations. That's what OBS stands for, observations. That means we slayed, in our little experiment, 1,482 aliens of 59 variables. And so if we go over here, we can see the columns are the variables and the rows are the observations. So let's just have a look at what kind of columns we have. We have what ship I used, what alternate fire I used, what shield type I used, what augment I used, how many lives I have left at the time each alien was created, obviously, or destroyed, I can't remember. The fire rate value for each alien. So now we're getting into values that each alien possesses. The alien's ID number, every alien has a unique ID number. What generation we're looking at for each alien. What its composite fitness value was, what its accuracy fitness component was, what its positional or aggression fitness component was, what its lifetime fitness component was. These things are combined into an aggregate fitness. Sorry. How many shots it fired. And then we get into weird genes where they're harder to explain. Shooting magnitude, let's not worry about it. We know who each parent was. So in this case, parents in the first generation, they have sort of a 0 parent value. We have what type the alien was. Remember, there's like 5 colors plus the base type, which is called larva. We have what shield type they were. And then we have a bunch of genes called morphology. Fire rate gene, which determines how frequently they're allowed to fire, how fast their bullets go. Bullet width, bullet height, that's like the size of the projectile. We don't worry about that. Shoot X and shoot Y. Those are, again, genes that have very technical and shoot bias technical meanings, and we don't really worry too much about them. These left-right things are movement genes, and there's a lot of them. These are the genes that encode the math so that in every tick of the game, the alien knows, okay, this is the environment, and therefore I'm going to move in this direction or that direction, up, down, left, or right. It's very complicated. We have a dominance value. We'll be working a lot with that. And then we have the genes that encode what kind of shield they will have. So it's actually an incredibly complex and rich data object. All right. We're going to simplify things in the next video, so don't worry about that. First thing that we're going to do now is save. We click this little disk button, and we're going to save our script as, let's call it Bio315 DD for Darwin's Demons. And then I'm just going to give it a 1 because we're probably going to build on these as we go. Hit save. Now you can see if this is red, it means you have unsaved changes. So if I start typing, I've got unsaved changes. If I delete that, and then I click save, and now it's black text, which means everything is saved and you're good. And this is nice because then you don't have to retype all your commands every time you've got a save file. You